Hey everybody, Chad German here. We're in a lab and we're going to do a quick video to show you guys voltage drop in action. So let's get started with that. So okay, here we have a circuit that is 120 volts. Right now it's just plugged into this little splitter. As you can see right here, we're going to plug this in and I'll show you the voltage. And we've got 120.5 volts. Okay, we've also got a little space or a little heat gun here, and this heat gun pulls 12 amps. So we're going to turn this on and we're going to see what happens to our voltage. You can see there that there was some voltage drop. Now we're going to go through and do this cord. We've got 150 feet of cord wrapped around the lab here, and it comes back all the way here, and we are going to plug this in and we're going to put the heat gun on and see what happens with our voltmeter. Look at that drop. So you can see here with a 150-foot drop, this is just extension cords with a load that you can tell is something that could probably happen in an everyday situation, and we lost almost 20 volts. And that's voltage drop in action for you right there. So in this video, you saw that we lost 20 volts after we had strung extension cords around the lab. We had 3 different size extension cords. You could see if we had an extension cord like this and it was 12 gauge and we had that solidly around, we would have probably lost less voltage because we didn't have a 16 gauge extension cord. Or if we would have had a 10 gauge extension cord, 150 feet, we would have lost less voltage. But if we would have had 150 feet of just nothing but 16 gauge extension cord, we would have had some major issues with even more voltage drop. We know that the voltage drop equation is 2 times K times I times L divided by Cm. And hopefully you guys understand how all that works. I'm not going to do a whole video on how to do that right here. I just wanted to give a demonstration on how voltage drop worked and how it really works. If we would have changed the amperage, if we wouldn't have had that heat gun at 12 amps according to what the nameplate said, and had something else, then we would have had a different voltage drop as well, because I is part of 2 times K times I times L. So you can't get voltage drop without the I. So where we checked voltage and it was 120, we didn't have any voltage drop. We put the heater on, and then the heater dropped a little bit of voltage because I is part of that equation. And then we added length, we added that back on, the I, and we had a bigger voltage drop. So changing the wire size, changing the amperage, changing even the type of extension cord. If we would have had an aluminum conductor in there, I don't know of an extension cord that has an aluminum conductor, but if you could find one, you would have had more of a dramatic voltage drop there too. So if you're watching this video from school, your teacher is going to show you how to do the voltage drop. If you're watching this video via YouTube and trying to learn more about electrical, know that when you use power tools and you just go string out a bunch of extension cords, your load, your amps will go up as your voltage goes down. It's Ohm's law. And you could ruin whatever piece of equipment you're running. So a vacuum won't be as strong. A Sawzall, a reciprocating saw, might go slower, and it's going to draw more on that load and possibly damage the equipment. So it's important to know about voltage drop. It's a real thing that everybody uses and everybody deals with on a day-to-day basis. And so hopefully this video helps you guys out and helps you in your journey to learn more about electrical work.